this shape, please don't make it gigantic because we're going to be doing some questions about it. Obviously, your pencil is not red and blue, so if you want to put an R for the red parts and a B for the blue parts, that would be great. We've got this shape drawn in our notebook. You don't have to write the question, we're just going to talk about it. So go ahead and draw this shape in our question or in our notebook. We've got a red section and we've got some blue sections. When I ask the question of what is the value of the red part, I'm asking what part is red. That's what I'm asking. So are you going to write it down? So what part is red? What part is red? Harper? 1/2 of my square is red. So out to the side, let's just put R equals 1/2. Because you're right, 1/2 of the square is red. That was pretty easy. That's an easy one to see. But when we start talking about blue, what's the shape or what fraction is blue? That gets a little trickier. There are 2 pieces that are blue. And there are 3 pieces there. Will, what do you think?
I think it's equal to 1/2.
You think it's equal to 1/2? Why did you think that?
Since they're big, if you split the red in half, it's 4ths, and then 2/4 equal 1/2.
Okay, so Will thinks that the blue is equal to 1/2. If you think that, give me 2 seconds. Will's thinking of it because he's imagining this shape, this red shape. If he picked that up and put it right on top of the blue shape, even though the blue is cut into pieces, he thinks that it would be the same size. How else could you think about this? How else could you think about it? Sean, what are your thoughts?
1/4.
You think 1/4? Okay, why do you think 1/4? Okay, so what we're noticing is right now they're not the same kind of fraction. We have a 1/2 piece and we have some smaller pieces. They don't look the same yet. So I'm going to take, and you do this in your notebook, I'm going to take that line that I used to split up the blue sections, and I'm going to go all the way across. Do I now have equal size pieces? Yes, every piece is worth the same now. That means I can count it. So if I have 4 pieces, 1, 2, 3, 4, what am I going to be counting by? 4s, because they're equal size now. Count with me. Ready?
1/4, 2/4, 3/4, 4/4.
How many do I have that are blue?
2/4.
I have 2/4 that are blue. Now, wait. Will said that it was 1/2.
It's equal to 1/2.
But we just figured out that it's 2/4. So, was Will wrong?
No.
We can do many different.
How do you know? How do you know? Michael, how do you know?
They're equivalent.
They are equivalent. I can use any version. So Will saying, oh, it's 1/2, and Sean saying, oh, it's 2/4. That's okay. Those are just different names. That is like you calling Devin Devin or calling Devin Dev. We're still talking about the same person. It's not changing. They're talking about the same thing. Yes, Lincoln.
They both equal the same thing.
Yeah, they're both equivalent. They have the same value. Do they look the same?
No.
No, 2/4 looks different than 1/2. We got different numbers in there. Yep.
It's equivalent because so say we have a number line and we have 2 number lines.
Yep.
And one has 4s and one has hat has halves.
Love.
If you just take away, well, if you literally just put the 4 number line into the like half number line kind of, then you can see that it's so equivalent because all it does is add it fourth if you just add it.
Beautiful, yeah. When we're talking about equivalent fractions, we've got to do a lot of imaginary cutting or partitioning in our head. And we did that just now. That red piece was not cut into 2 pieces, but we did it so we could see it. Shelby?
Because, like, say you split a square into eighths, and then you shade fourths. It's still shaded the whole half.
Yeah, awesome. All right, we're going to draw another shape. This time I want you to draw this shape, a little bit different. We're going to be talking about the yellow sections and the purple sections. So if you want to label them yellow or Y for yellow. It is. It looks a little crazy because it's on a green background, but it is purple. The question we're going to start with, what is the value of the yellow part of the shape? AKA, what part of the shape is worth yellow? What part of the shape is worth yellow? Shelby? How do you know?
Because all the purple takes one space, even though there's lines in between it.
Love. Yeah. Shelby says, I know that all these purples, even though they're already cut, if I kind of pretend that they're not, I've got 2 equal sized pieces. That means I'm talking about halves. Yellow is equal to 1/2. That's going to be the best name for it. So just like we talked about that 2/4 and 1/2 are equivalent, it wouldn't really make sense for me to say that yellow is 2/4. It doesn't show 2/4. Yes, those are the same value, but that doesn't quite match our picture. You talking about yellow or are we moving on to purple? Hang on to it. All right, so let's go down to purple. Once again, we know our yellows. What about purple? There are 3 pieces of purple there, right, Mason? Mm-hmm. And I see 4 pieces total. So is it 3/4? No, that yellow piece is way bigger than those purple pieces. That would not be fair. What you thinking, Harper?
The purple's 6.
How do you know that?
It's 6 because the 1/2 takes up the other 3 pieces that goes with the 6. Because if you take all of those three purple pieces and you like take them to the yellow, it's the same size, and also it would make the same amount of lines and the same size.
Beautiful. Yeah. Right now, I can't count my pieces because they're not the same size. So I can't count them yet. I have to imagine that I've cut up my yellow or I've put those purple pieces on top so that now I have all the same size piece. You see that? Now that I have all the same size piece, now I know what I'm counting with. There's 6 of them, so I'm counting with 6. Count with me. 1 6, 2 6, 3 6, 4 6, 5 6, 6 6. So how much is purple? How much is purple? Mason? 6. Not 6 6. 6 6 would be all the pieces, because 6 6 is equal to 1 whole. All of those pieces aren't purple. Only some of them are purple. How many pieces are purple? 3 of them, and I'm counting by 6, so it would be 3, 3, 6. another name I could say instead of 3, 6? 3, 6 is probably the best name for that fraction. Is there another name? 1/2. If I think that yellow is 1/2, this piece is 1/2, that must mean that the other side is 1/2, even though it's cut up into smaller pieces. So 3, 6 is equal to 1/2. They're equivalent. So far, so good? All right. Today, we're playing with geoboards.
What?
You've seen a geoboard. You might have even used a geoboard.
I've played Apple.
Awesome. So this is what a geoboard looks like.
Yes. That was like
You might have used older ones. I do have some really old ones that are wood and then have almost like nails sticking out.
Yeah.
So
Like
I like to use the plastic ones because they don't bend so much, and I've had these for a couple of years and they still look fine, so there's no reason we should be breaking our geoboards. There are 2 sides to a geoboard. One side, as you can see, has lots of squares on it. If you look closely, you can see the squares and our pegs. The other side has circles on it. You can use either side today, but there should be rubber bands on both. Because the way that we use a geoboard is we use these pegs to make shapes with rubber bands. So I'm going to go over some rules. I'm going to go over some rules and then I'm going to show you how, and then we'll get you started. All right, first rule, we're not spinning them. I know there's a peg right here. And this is like the perfect thing to do. But that is how this peg breaks. So please don't spin. I don't care how you want to attempt to spin. We're not spinning them. That's not what they're for. Please don't play with the rubber bands. So these are old rubber bands. They will break. I'm not upset if they break. It's fine. I expect some to break. But don't be playing with them. We're not trying to push them all the way here and then draw it back and then be surprised when it goes shooting across the room. You knew what was going to happen. Alright, I want to show you how to make a shape. I'm going to show you how to make a shape with the geoboard. We've got a couple of different strategies. So my favorite way, if I'm making a small shape, is just to use one rubber band. I say small for a reason. If I wanted to make a square, a 2x2 square, I would use one rubber band to go all the way across the whole thing. Okay? I made one square. We see that? Yeah. Now, if I'm making a bigger shape, this little rubber band might not do it. So what I do is I use it as the lines in the shape. So there's one line, another one. Here's another line.
Well, some of them be stiff.
They will be stiff, yeah. That's why I said some of these will break, and it's fine. They're old. Here's another line.
Don't break the last one.
And then here's another line. So you can use your rubber bands as lines in the shape, or to make the hole.
I didn't know that.
What we're going to be doing is we're going to be making some fractional values. Before I show you how to do that, though, I'm going to go ahead and give you your board, and you can practice making shapes, just exploring for a little bit. You can do them on the front and the back. So I'll give you some time to explore, and then I'll show you what we're doing. Lincoln question.
We're excited.
All right, crew, I need all rubber bands off your geoboard, please. Go ahead and take them all off, put them back in the pile. All right, so we are going to be making the shape both on the board, and I'm going to show you how to draw it, because tonight you're not going to take a geoboard home, but you will have a geoboard paper like this. You have this one in So the way this game is going to work is you are going to get a fraction dice, same fraction dice we've been working with, the green one. You know they have 1/6, 1/8, 1/3, 1/12 that we have renamed 1/8, and then 1/2. With you and your partner, you're just going to roll it, and that is the shape that you're going to try to make. So I just rolled a 1/8. So we're going to try and make 8 on our geoboard. So go ahead, start trying to make a shape that is partitioned into 8. If you think you've got it, give me a secret thumb. Nope, we're doing it on our geoboard right now. Go ahead and get this paper in front of you and a pencil. So we made, the numerator was 1, the denominator was 8. We made 1/8. Actually, we made lots of 8s. We're going to draw what we made. I'm going to draw one example, but if you have a different one, yours might look a little different. Just like where I have rubber bands is where you're going to draw. I'm going to draw the version that Michael had, which a couple of you had as well. It looked like this. Again, if you had something different, you might draw something different. Pause, look at my board first. Pause, look at my board first. So Michael started with a large square, connecting all my dots, my pegs. Then he did one going down, and then 4 rows across, just like that. Does this make sense?
Yes. Yeah.
Alright, so draw what yours looks like. If it looks like mine, that's fine. Absolutely not, that's how you lose your board. Draw what yours looks like. So we made 1/2 on our geoboard this next time. Go ahead and draw the version that you did. Alright, so we've got our tabs made. Yep. Once you finish drawing, you can take it off. Alright, the last one we're going to do, I know it doesn't look like this on our board, but I want to challenge you a little bit. Once you get your rubber bands off, turn your board over. I want to see if you can make 1/2 on this side. It's going to look a little weird when we draw it, but see if you can figure out how to make 1/2 on this side. We did it on the circle side, so we might have to draw it as best as you can if you did, especially if you did a circle model.
How do you do a triangle model? Yeah, if you do a square.
So if you did a triangle, well, we could do something like this.
You could do a square.
It wouldn't quite match the pegs on the paper version, but you could have made it work on your geoboard version. Alright, take your rubber bands off. Move your geoboard to the